7.5 Exponential and Logarithmic Equations. Our objective today is to solve exponential and logarithmic equations. Problem number 1, solving an exponential equation with a common base. So the question is, what is the solution of 16 to the 3x equals 8? So first we will write the problem. Then what we're looking at is 16 and 8 don't really have anything in common the way they are, except if you rewrite them as 2 to a power, because 16 is 8 times 2, 8 is 2 to the third, so 16 is actually 2 to the fourth. We already know that 8 is 2 to the third, so I'm going to rewrite each of these first. 2 to the fourth to the 3x power equals 2 to the third. Now, when we have a power to a power, we're going to use the power property, which means multiply those exponents together. So 2 to the 12x equals 2 to the 3, and now the bases are the same, so the exponents have to be the same. And then all we're going to do is divide by 12. So x is equal to 1/4. Okay, you can check it if you want to. 16 to the 3 times 1/4, or 16 to the 3/4. You're going to check to see if 16 to the 3/4 power equals 8. You can just type that right into your calculator. 16 raised to the 3/4 power, oops, I'm going to type that in one more time, is 8. So it is okay. And we'll check it and move on. So if you want to pause right here and try the got it question number 1, go ahead. So I'm first going to rewrite 27 and 81. 81 is 3 to the 4. 27 is 3 to the third. We're again going to use that power property. Power to a power means you multiply them. Since the bases are the same, the exponents have to be the same. And we'll divide by 9 to get our answers. Okay, again, 27 to the 3 times 4/9, that would be 4/3, should equal 81. I'm going to try that. 27 raised to the 4/3 is 81. So it does check, and so we're good to go. Problem number 2, what do you do when you have different bases? So what is the solution of 15 raised to the 3x equals 285? 15 is 5 times 3, so that doesn't go down anymore, but 285 probably could, but even so, they don't really have anything to do with each other. So 15 raised to the 3x equals 285. Now, what we're going to do is we're going to take the log of both sides so that we can put them and make them in common with each other. So we're going to take the log of this side as well as the log of that side. When we do that, our base is 10. You can write it or not write it, whatever you want. And then what we're going to do, it looks like this. And then what we're going to do is we're going to swing this 3x down in front. So when we do that, it looks, sorry about that, it always scans to the top. It looks like this. Oops, not equals. Okay, so anytime you have an exponent, you can either swing it down in front. If it's front, you can swing it up to the exponent. And that's called the power property. So we want to solve for x, so we're going to divide this thing by 3 log 15. You can put the 10 in if you want to. and divide the other side by 3 log 15 as well. There you get x equals, and if you go to 4 decimal places, 0.6958. So remember 4 decimal places. Also, remember when you're typing this into your calculator, it's going to throw a parenthesis there. You need to finish out that parenthesis before you type in the divided by part. If you want to pause here to try got it question number 2, go ahead. So got it question number 2. 5 to the 2x equals 130. So we will take the log of each side, and we'll bring the 2x down in front. So it's going to look like this. 2x log 5 equals log 130. To solve for x, we'll divide by 2 log 5. And x is going to be approximately equal to 1.5122. Go ahead and check that. Here, it's going to be approximate because we rounded it at the end. If you actually use the full value, it would definitely equal 130. Otherwise, it's just going to be close. Solving log equations. So here, you have to be mindful that there's log on one side, not on the other. So we definitely want to make use of this base 10. So the first thing we're going to do is rewrite it as an exponential. Remember, the 10 swings over, the 2 becomes the exponent. When the 10 swings over, there's no more log in the equation, so it looks like this. 4x minus 3 equals 10 to the 2. That would be 4x minus 3 equals 100. Add 3 and divide by 4. Which is approximately 25.75. Again, you can plug it in. If you keep the 103 over 4, it should hit 2 exactly. If you only type in 25.75, it's probably going to be close to 2. You can pause here and practice got it question number 5. So I'm going to swing the 10 over. So you get 3 minus 2x equals 10 to the negative 1. And 10 to the negative 1 is like 1/10. You can write it either as a fraction or a decimal, whichever you want to do. Negative 2x equals negative 2.9. And divided by negative 2. X is approximately equal to 1.45. Check it. Again, we rounded, so unless you leave it in decimal form, it will not equal negative 1 exactly. We rounded, so it should come up with something close to negative 1. And the last set of questions, problem number 6, using log properties to solve an equation. So with this one, notice the 2 items on the left have logs in them. The one on the right does not. So we want to condense this first, just like you were doing yesterday. So since there's a plus in the middle, that means we're going to multiply those parts. So log x minus 3 times x equals 1. Here is where the exponent comes in. We're going to swing it across. So we get x times x minus 3 equals 10 to the first, or just 10. Multiplying this out, x squared minus 3x equals 10. We'll bring the 10 to the left by subtracting. X squared minus 3x minus 10 equals 0. We're going to solve by factoring. Oh, not 7. Minus 5 plus 2. Solve each one by setting each one equal to 0. So x is going to equal 5, and x plus 2 equals 0. X will equal negative 2. Now, when you're solving these equations, you definitely have to throw them back in to check out if they work. So what we're checking for here is, I'm going to do this above, log 5 minus 3 would be log 2, plus log 5 should equal 1. So you can plug that into your calculator. Log 2 plus log 5 hit equals, it should be 1. You also have to plug in log negative 5 plus log negative 2 equals 1. This one I can already tell you is not going to work because we cannot do logs of negative numbers. Make sure that when you put them together, they're a negative number, not just separately. So I'm going to cross this one out. It doesn't work. 5 is my only answer this time. If you'd like to pause and try got it question number 6, you can do that now. So this time we have a subtraction, which means division. So log 6 divided by 3x equals negative 2. There's a 10 here. We're going to swing it over. So we'll finish solving. Ignore the music in the background. It just hit 3:30 today. So this one looks like 6 divided by 3x equals 10 to the negative 2. I'm going to fix that power on the right so that it's positive. 6 divided by 3x equals 1 over 10 squared. 6 divided by 3x equals 1 over 100. And if you cross multiply, you get 3x equals 600. X equals 200. Let's check it out. So we'll have log 6 minus log of 600 should equal negative 2. I multiplied 3 times 200 to get this 600. When you throw that in there, it does work. So this answer is correct.